Alright, so here we have the Moody diagram, and this video is pretty much just going to be practice reading the Moody diagram and make sure you know how to read the scales and all that kind of thing. If you are pretty confident on your ability to read the Moody diagram, then this video is obviously not necessary for you to watch, but it's a good review and practice for the test this week and the final as well. So we're going to start off with this table that I've made just with some random values just to get some practice in reading this graph. So we always want to start when we read the graph with the Reynolds number. So in this first example, we have the Reynolds number equals 1000, which is 1 times 10 to the third, which is right here on the graph. And I have put this Ks over d value here, but it's completely unnecessary, and it's probably just going to be there to trick you, if it is there, because this is a laminar flow, and laminar flow is only a function of the Reynolds number. Ks over d has absolutely no effect on laminar flow. So what we want to do is draw a line straight up from our Reynolds number, which is 1 times 10 to the third, which is right here. And we go straight up to where it meets this laminar flow line, and then we just read straight to the left side of the graph, which is our F scale, and this value is going to be approximately 0.060, and that's it for the first one. For the second one, we have a Reynolds number of 1.5 times 10 to the third, or 1500. So 1.5 is actually right here, and if you'll notice, here is 1 times 10 to the third, and here is 2 times 10 to the third. And this tick mark here is actually closer to 2 times 10 to the third, and that's because this is a logarithmic scale. You got to be very careful about that. If you read the value right here, which is if it wasn't a logarithmic scale, you're going to get a little bit of a different answer, and that's definitely going to be multiplied in this middle section here. So if we read from 1.5, which is this tick mark here, straight up, kind of straight up, and once we hit the laminar flow line, we read straight over, and we get about 0.038. Again, you just have to look at this scale. So this line here is 0.04, and this line here is 0.03, and we have 4 tick marks in the middle, so that must mean that this one right here is 032, 034, 036, 038, and 040. Okay, moving on to Reynolds number of 200,000, which can also be written as 2 times 10 to the fifth. So we find 2 times 10 to the fifth, which is right here. We draw a line straight up, and then we find the, and also, again, sorry, on this second example, this is 0.060. That's just there to confuse you. You don't need that value at all. It has no effect on F. Now we need to find 0.01 on Ks over D scale, which is right here, and that's this line here. So we're just going to read that straight across, straight across, straight across, until we come in contact with our line, which is right there, and then we just read that straight across to the F scale, which again is somewhere around 0.038. Our next problem here is a Reynolds number of 3 times 10 to the 7th. So here, right here, is 1 times 10 to the 7th, 2 times 10 to the 7th, and then 3 times 10 to the 7th is in between the 2 and the 4 times 10 to the 7th. So we have 3 times 10 to the 7th. We draw our line straight up. Again, if you're on an exam, you're going to want to try to draw these lines a little bit straighter than I am. Just for the sake of time, I'm not really being very careful. And our Ks over D value is 000 or 0.0002, which on the graph is right here. So we read this line straight over to this value, and read this over here. That's wrong. and we get approximately 0.014 for a value for KS, or for F, excuse me. So again, on a test, if you did what I just did and you're not very careful, you can come over here, you can draw this line, and then you can start like creeping downward and read a value here. That's obviously not right. So you just have to be careful when you're on an exam or homework or anything like that, to make sure that you're drawing straight lines. Okay, next we have a Reynolds number of 40,000, which is 4 times 10 to the 4th. So we find 4 times 10 to the 4th, which is right here. Draw our line straight up. And then we find our KS over D value, which is 0.0005, which is actually going to be in between 0.006 and 0.004. Again, KS over D is on a logarithmic scale, so this value is going to be a little bit above halfway between these 2 points. So we start drawing our line, and we draw it straight across until we hit this dashed line here in the middle of the graph, and then we need to follow the trend in between these two lines. So it starts to curve, starts to curve, starts to curve, and we get to right here. Again, you need to make sure your lines are a little bit better than mine. And then we just read straight across, and we get a value of approximately 0.023. Yep, okay, so that's that example done. And for the final example, we have 3 times 10 to the 4th for our Reynolds number, which is right here. Yeah, so again, as you can see, this right here is 3 times 10 to the 4th. This tick mark here, and that means this one right here is going to be 3.5 times 10 to the 4th. This is a logarithmic scale, so this 3 is not actually right in the middle of the 2 and the 4. So it's just something to note when you're reading these scales. So we have our Reynolds number, we draw our line straight up, and we find our 0.003 KS over D value, which is going to be somewhere in between here. And remember, it's going to be more than halfway up since it's a logarithmic scale. So we read straight across until we hit our dotted line, and then we start following the curve or the trend of these curved lines, which is somewhere around there. And then once we hit our intersection point, we draw our line straight across, and we get approximately 0.030. So yeah, this was just a little practice for reading the Moody diagram. The logarithmic scale is probably the part that's going to trip most of you up. Yeah, that's something you just need to know how to read, is loads of log scales, and hopefully this helped. Yeah.